Hello, 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 folks, and welcome back. Root Beer here with more of the 2002 Grade 9 Pascal contest, another math contest brought to you by the University of Waterloo. And we're on question number 15, so we're halfway through part B, where each question, if correctly answered, is worth a total of 6 marks. Okay? So question number 15, what does it have to say? In the diagram, ABC represents a triangular jogging path. Jack jogs along the path from A to B to F. A to B to F. Jill jogs from A to C to F. Each jogs the same distance. The distance from F to B in meters is, all right. Well, I notice here I have a right-angled triangle. It's right-angled at A, and so I might not be able to figure out F to B or F to C immediately, but because I have the legs of this triangle, my instincts kick in, and I think, well, we can use the Pythagorean theorem, and I can figure out what BC is right away. So let's go to the notepad. Now, before I do that calculation, put our point F on here. I'm going to give the name of, we want F to B, so we're going to give that a name of X. Don't know what exactly X is, but I want to put that there at the very start so I know that this is what I want. I want to solve for X overall. Okay? Now we have, I think it was 160 down here and 120. We're in meters. Yeah, 160 on the bottom and then 120 for AC. And we have this handy right-angled triangle. And because we have a right-angled triangle, we can use the Pythagorean theorem so that says if I have a right-angled triangle and I've got A, B, and C, A squared plus B squared is equal to C squared. This works for every right-angled triangle. So that tells me that BC, all squared, so that length, is going to be AB squared plus AC squared. Well, I know what AB is. It's 160, so I want 160 squared plus 120 squared. And I can work these out on my calculator. Okay. So I get a total of 40,000. Now, if I just want BC by itself, and I do, I want more information. I want as much information as possible. Well, that's the square root of BC squared, and so that's just the square root of 40,000. Okay, square root of 40,000 should be 200, and if we wanted to get technical, 200 meters, although we don't need to write that if it's our own personal notes. Okay, sometimes it's helpful to keep units around to make sure you're applying equations correctly, like making sure that your surface area gives you centimeters squared instead of centimeters cubed, things like that. But I don't really need that right now. So now I know this total length here is 200. Okay. Well, I said FB is X, so that means this must be 200 minus X. And now we can use some extra information. We know Jack goes from A to B to F. So that means he does 160 meters plus X meters. And I know Jill goes from A to C to F. So she travels a distance of 120 plus, what's the distance from C to F? That's 200 minus X. So Jack goes 160 plus X meters, and Jill goes 320 minus X meters. But we're told that they traveled the same distance. So that means 160 plus x must be the same thing as 320 minus x. We can bring all our x's to the left-hand side and all our numbers to the other side, to the right-hand side. Divide by 2, and we're left with x is equal to 80. And I know I'm done because I have the x value that I wanted. I started the question saying, this is x, this is the thing I want, the distance from F to B in meters. And now I have my x value. Let's just find it on our list. There it is. It's hiding in the corner. It's an answer of D. So there we go. That wraps up that question nice and neat. And we're going to move on to question number 16. But we'll have to wait for that till the next video.